The stoppage of the railway system in Stockholm was due to an outage in the transmission network. The outage was produced due to a disconnection of several megawatts of load, which had repercussions on other equipment and apparatus. So then we just went black. Reprocessing now. We carry a research that aims to reduce the risk of these events by developing new technologies. So what we're trying to do in our research and in the lab is to develop new flexible tools that can be used to monitor power system dynamics. So when the system is shaking, we are able to detect it and do something about it. The currently available technology only provides you with a few measurements every 4 to 5 seconds at most. That puts a limit on the options that you have to exploit this data. If you have high-speed measurements, like the ones that we are using in the lab to develop new tools, then you have the possibility of monitoring and controlling faster behavior. Such behavior is what we're seeing with the integration of the new renewable energies. It's a real-time hardware-in-the-loop lab. What it means that it allows us to connect a power system model directly to actual equipment and harvest measurements from that equipment just as you do in the real network. The tools that we want to develop should be able to provide to the power system operator information when he most needs it, and also to take control over actions that are too fast for a human being to react. So we want to automate a lot of the process that goes on in the operation of the power system and its control. These methods and new tools, new software will be most useful when we're facing challenges of integration of new renewable energy. As we are already seeing today, it's quite hard to keep track of intermittent generating sources because they're fast. So we need a faster system to react, and we need a finely tuned control system to take care of any problem. We are already facing many challenges for the safe operation of the power system. One example is in Germany, where they have phased out all of their nuclear energy, but the operators don't have the tools to be able to manage all of the incoming renewable energy that is meant to replace it. So we need to develop these tools not only to have safe operation of a power system, but also to be able to exploit intermittent generation sources such as wind and solar. We're only at the beginning of the development of this lab. To be able to achieve the vision and to develop the technology, the methods, the tools, the new software, all of these ideas, we need an increased support from the industry and to be able to connect with the right research partners so we can accomplish the goals that we have set out for. There's no IT system in the world that can create secure grids by itself. It needs new software tools that allows for better monitoring and control of power systems. So having an advanced IT infrastructure without having the new tools to operate it is like having a Ferrari without the knowledge to drive it. It's, in the way I see it, the only way to have a smart grid is to have new good controls that give you a driving license for that Ferrari.